Okay, today we're going to talk about cross sections. And cross sections are two-dimensional shapes after you have sliced into a three-dimensional shape. So our essential question today is, what shapes are the cross sections of 3D figures? So we start with the idea that a cross section, like I just said, is the two-dimensional shape created by slicing a three-dimensional shape. So we're just gonna figure out what shapes make to be able to, when we slice something. So if you look at the first examples, you can see that there are different kinds of slices. We're gonna focus on horizontal and vertical slices. Some videos that you see, if you Google this, will show you different ways to slice, but we're gonna focus on just horizontal and vertical slices. So a horizontal slice, if we have, this is a cuboid, or, spelled that wrong, cuboid, or a rectangular prism. And if I slice it, you can see that the shape is a rectangle or a square, depending upon the shape of the prism. If I vertically slice that same shape, you'll see that this is the direction that I slice it. So you can see that when I cut through the shape, that I again get a rectangle or a square. So it just depends on how we cut it. This is another rectangular prism, and it is also a rectangle when we have a horizontal slice. This is a pyramid. It's actually a triangle pyramid. And a vertical slice would be a triangle or a trapezoid. You can see that it's a trapezoid because it has a flat surface here and here, or parallel surfaces, excuse me, and two not parallel. But if I go all the way to the top, then that would be a triangle. So it can be either one of those. This is a triangular prism. And when I do, that's a vertical slice in the picture. But if we do a horizontal slice, horizontal would go this way, and that would be a trapezoid. If we do vertical slice, then that's a triangle. It depends on how the shape is. Notice that it depends, technically, because it's a triangular pyramid, this is the base. So if we stand it up on end, then that's why we get the shape labeled as such. The last one is a cylinder. And when I do a horizontal, then I get a circle. This is a sphere. We get a circle when we slice it anyway. And this is a square prism, or square pyramid, excuse me. And we get a triangle when we slice it. So let's look at some of the other practices. Let's just go through it again. When we do vertical, so that's slicing it like this, what shape am I going to get? A rectangle, just like the bottom. And when we do horizontal, which would be this way, then I'm going to get a triangle. This is a sphere. So for vertical, it's a circle, and for horizontal, it's a circle. This is, it has 6 sides. So this is a hexagon prism. Prism, I spelled prism wrong. Prism. And if we slice it vertically, so if I take a slice like this, that's going to be a rectangle. And if we do it horizontally, which looks like this, it will be a hexagon. So this isn't designed to be difficult, it's just to make you think about which way we're slicing it so that you can find, especially when we start talking about the base, what the base is and where to find it. This is a cylinder. So horizontal would be slicing it like this, and that's a rectangle. And vertical would be a circle. Circle. And that would look as if we sliced it like that. All right, so here's a couple of word problems just to take those a little bit further. Leonard will slice a cylinder into 2 congruent pieces. List all the 2-dimensional shapes that could result from this slice. So it's a cylinder, just like this one. So if we slice it vertically, I'm going to get circles. And horizontally will be a rectangle. If we vertically slice a rectangular pyramid, so that looks like this. So I have a rectangular pyramid, and if I slice it vertically, that would be something like this, and that will end up in a triangle, or depending on where I slice it, a trapezoid. Remember that trapezoids have 2 parallel sides and 2 not parallel sides. If we slice a triangular prism, so that means that I have a triangle here, and it goes like this, so that I have this triangular prism. And I'm going to slice it horizontally, which is across like this. Then I will end up with triangles as my cross section. So that's all there is to cross sections. It's just being able to identify them because we're gonna need that for finding the base of prisms as we do volume and surface area.